Okay, so you see I just walked over and clicked on the iPad because everything I do is video, okay? Now, why do I do that? And yes, why do you think I video everything?
Do you get confusing just watch back?
Exactly. And if I go too fast, which I tend to do sometimes, because we have so much math to do, you can always pause it, catch up, start it again. Why else do I video? If you're not here. If you're not here. I am not going to worry about it if you're not here, because you're going to know you're sitting in the class. When you watch the video, it's like you're sitting in the class. It is up to you to find a time to watch the video. Okay? Because understand, if you're absent on Monday, we're not. We're here having class, and when we come in on Tuesday, we're starting up right where we left off. So you need to be up to speed. All right?
Is it just going to be like posted every day, or do we have to ask for it? Oh.
No, it's going to be posted. Now, that brings me to the next thing. I am 65 years old, okay? They throw Canvas at me like, wow, I just figured out Schoology, sorta. So, your Bible is the handouts I give you and what I tell you in class, all right? Because there is no guarantee that I'm going to get things into Canvas correctly. I think I'm good. I've got stuff in there right now. I think it's okay. But don't come in and say, oh, I couldn't find it in Canvas. Because you know what? I gave it to you. Right here. And I told you in class, all right? So don't rely totally on Canvas, because I'm telling you right now, I'm not techno at all. Okay, I can't figure out my phone. I can't figure any of that stuff out. So I'm going to do my best, but I'm always going to be prepared with hard copies. You're always going to have hard copies. I video post it. It's in YouTube, but my intent is I always put the links in Schoology, so you can just go there and do it. But if not, you'll have to find me in YouTube. Trust me, I have thousands of videos out there. So you just want to find the one that's appropriate for today. Okay? All right. Not going to spend much time on this syllabus because you guys have been down this road before. You can read and whatever. There's one thing that is a little different, I think, for you than in the past. First of all, I don't assign very much homework. Your job is to do what I assign thoughtfully and carefully. If you need more practice, oh yeah, we got a book posted in Canvas, and the book is in there. You can always go find more practice, but you really need to focus on the homework that I've given you. So how does it work? This is the part that's different. So we're going to start P1 today. We're not going to finish. Chapter P is the prerequisite chapter for the class. Then we'll start Unit 1, and then we'll do Unit 2 and Unit 3. There are only 3 units tested in AP Pre-Calculus, but they are huge units. But these are the prereqs. These are things from algebra that's like factoring cubic equations. Those are things you need to know how to do before we even start in the units. So we're going to practice all that. So if you look at your homework packet, you will see that the first page of the homework packet says Homework P1. Notice that it's front and back. That is all of the homework for section P1. So there is a page front and back per section, okay? Today we're going to start P1. We have short periods again tomorrow, so we may not even finish P1 tomorrow. But let's say we do. Let's say I get P1 done tomorrow. Then I will say to you, okay, that's P1, homework due Tuesday. So if I finish it tomorrow, you get a grace day, and then it's due Tuesday. Now, it's due Tuesday whether we have class or not, okay? I'm giving you an extra day to get it done. If you want to turn it in Monday, I am A-okay with that, okay? But because some of you have volleyball games, and you have swim meets, and you have all kinds of stuff, I give you a grace day. So homework is due the second school day after we finish the unit. What we don't have class. Bring it in, put it in that yellow plate right there. When do I bring it in? Whenever you want. So if you want to bring it up during lunch, fine. If I'm teaching, fine. Just walk in quietly, walk over and put it in the plate. If I'm not in here and the door is shut, slide it under the door. If you do that, you might want to shoot me an email. Hey, Miss Ford, I slid something under the door. Okay? If you're sick and it's due, take a picture of it and email it to me. Is that good? Does everybody understand the rules? Okay, now listen. There's a school rule that says, I'm a teacher of a school rule, that says I can't make things due on a day when I don't have class, okay? I'm making it due on a day I don't have class. Sometimes for you it will work out that way because it actually should be due the day before, but I'm giving you an extra day, right? If it bothers you that we don't have class on Tuesday, then bring it Monday. Do it, get it in, turn it in on Monday. But if you need an extra day, you have till Tuesday. Homework, I expect you to try. If you could get every problem right, you'd be teaching class, right? I don't expect perfection, although that would be great. But I don't want you photomapping. I don't want you going whatever sources you all have. I don't want you copying off each other. No. I want you to try. When you turn it in, I will grade it. The answer key is always going to be up here. You'll come up and check your answers anytime you want. You can come in before school, after school, whatever. I just want you to work on it. Think about it, work on it. Okay? No penalty for missing. If you miss them all, yeah, I'm not going to give you 10 out of 10 if you miss them all. Because there's no one in this room should miss them all. But if you miss 3 or 4, okay, you tried. And we'll figure out what you did wrong. Got it? Okay. I was talking about this with a transfer student yesterday. When you've been doing this for 44 years in the same school, you get a reputation. And sometimes that's bad and sometimes that's good. So some of you are sitting there thinking, oh my God, she's so old and she's so mean and she's so hard and blah, 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 blah. No, I'm old, that part's true. This is a hard class. Although frankly, the AP version is a little easier than the old honors version was. But I'm not mean. I enforce the rules. Okay, I enforce the rules. If you do your job, I'm not going to be mean to you. Wear your lanyard, be on time, do your homework, put your phone in the door. I don't want to hassle with it, and I'm not going to warn you. There are no warnings here. You are juniors and seniors. You know the rules. You're in an honors class. As long as you act that way, we're going to get along fine. And this is going to be your happiest period of the day. Yep, I'm not kidding. Math League sign up, start tomorrow and run through next week. Everybody should be signing up for Math League. If you are interested in a t-shirt, we have cool t-shirts this year. They say, make your problems disappear, multiply by 0. No one's even smiling. Those are awesome shirts, but anyway, those are optional. Those are optional. I have forms. I think I put it in Canvas, but if I can't find it or it's not there, I have hard copy forms up here. $4 starting tomorrow through next Friday. We cannot go past that. We cannot be late because the student fundraiser is starting and we can't collect any money during that time. So next Friday is it if you want to do Math League. Are there points associated with Math League? Of course there are, but you shouldn't do it exclusively for that reason. You should do it because you just love coming in early and doing math, right? Anybody have any questions? Yep.
Oh, that's unfair.
Yes, again. But should that happen again, we would be in trouble, okay?
He's a junior.
Phones
That's big out for
go,
he's a junior.
phones go in the door. Look at this. Now,
doesn't follow the rules.
The tape is running.
I'm a
Busy
rule
on
follower.
all this. This is the board I'll use when I video because it's there and this is the one that I can see. So tomorrow when you come in, sit where you want to sit until I learn all of your names. Okay? Until I learn all of your names. All right, so speaking of which, let's do it. Mr. Art. Bat.
Here.
Lusac.
Here.
Bushong.
Here.
DeBroda.
Here.
Espinoza. Griffith.
Here.
Heiser. Hughes.
Here.
Johnson.
Here.
Lewis.
Here.
Marks. Minch.
Here.
O'Brien.
Here.
Pack.
Here.
Pastorino.
Here.
State. Did I say that right? State. Sweeney.
Here.
Trowbridge. Hugo.
Here.
Watson.
Here.
Watson.
Here.
Zink. All right. No more questions? Everybody brings back your yellow sheet signed tomorrow so I can give you points for that. All right, let's get our notes out.
We didn't get the yellow.
Oh, they're not yellow, though. I'm sorry. We have that tomorrow signed, yes. All right, let's get started, get through as much of this as we can. We need some definitions. Anybody know what the natural numbers are? Oh, no. Not a good way to start. Anybody know what the natural numbers are? Starting with 1,
Not 0 though.
not 0, starting with 1,
1 to infinity.
going all the way to infinity. So every number from 1 to infinity?
No.
Whole numbers.
Whole numbers.
The natural numbers are the numbers that you naturally learned as a young child. When your mom or dad or aunt or brother, whoever sat down and counted with you, they started with 1, 2, 3, right? Those are the natural numbers. Now, when we stick 0 in, then we have the whole numbers. It's a natural progression. Think about when you were learning your numbers. You learned these, and all of a sudden you needed a concept for nothing, so we threw 0 in there. And this is the definition. There is no verbal definition for these. They are rosters. The roster of numbers. Okay, now we have integers. Anybody know what integers are?
Positives and negative numbers. Whole numbers.
So these guys right here, the positive and negative,
Hold on.
I told my summer school kids who were teaching summer school, I said, if you draw a number line and you start labeling your number line, the numbers that you label on the number line, when you build your number line, those are the integers. Now, what about rational? What are rational numbers? They include fractions.
It's got like an end, right? Like it can't go on forever.
Actually, decimals can go on forever
Oh, wait.
as long as
It's a
they
pattern, right?
repeat. Yeah. So we have 2 definitions we're going to get used to, and I don't care what letters you use. I'm using A and B, but we're going to say the set of all numbers A over B, where A and B are integers. So in other words, build a fraction out of these guys. And B cannot be 0, obviously, we can't divide by 0. So that's one definition of rational numbers. So somebody said fractions. Yes, as long as the fraction consists of these numbers, top and bottom, you're going to be rational. The other definition somebody said about decimals, the other definition is either repeating or terminating decimals. Now in a minute, we're going to talk about converting from this definition to this definition. How do you change fractions into decimals? How do you change decimals into fractions? Those are the definitions for rational numbers. What about irrational?
Which they can't be written as a fraction.
So in other words, actually, you gotta be careful with that, because root 3 over 2 is a fraction, but it's irrational, because it's not composed of integers. So normally, we could say that, that would be a long definition, we could say that. Normally, we just say they're non-terminating, non-repeating decimals. And what's the most famous example?
Pi.
Pi, absolutely. Look over there on the sideboard. How cool is that? Last year on Pi Day, I walked in and that was written on the board. The Pi Day fairy came in and wrote down on the
I know, like the first 50 of that.
Huh?
I like memorized in like fourth grade. They count us 100.
No, 100?
No.
That's insane. Wonderful but insane. Okay,
There you go.
next.
Wonderful, but insane.
What are the real numbers? I'm gonna start erasing here. What are the real numbers? What do you think?
Is it everything that doesn't have like an I?
Well, if it's got an I in it, that means it's imaginary, right?
Yeah.
So, that probably isn't the best definition in the whole wide world, but it's exactly right. It's exactly right. The real numbers are the union of the rationals and the irrationals. So in other words, if you had a big bucket up here, and you had a pail of rational numbers, so the repeating and terminating decimals, and another pail of the non-repeating, non-terminating decimals, and you dumped them all together, that would be real numbers. Those are the real numbers. And then we've got pure imaginary and complex. Anybody know what a pure imaginary number is?
The number with the I?
So, an example would be like 6i, right? So we say, when we define it, we say vi, where v is what?
Integer.
A real, no,
Oh,
that
a
needs to
real
be an
number.
integer. It needs to be a real number, so that's a symbol for real numbers. V is a real number, and I is what? What is I?
Square root negative one.
Square root of -1. I is called the imaginary unit. Square root of -1. So anything I, so it doesn't have to be a whole number or an integer, it could be root 7i. Normally, if it's got a radical, we put the I before it, so we don't get confused about where that I is. You can actually take the square root of imaginary numbers, so you want to be real careful that you got it right spot. And then complex numbers are anything in the form a plus bi, where a and b are real, and I is the imaginary unit. So you have seen these numbers a lot when you solve quadratic equations. Remember doing the quadratic formula and getting answers that look like -6 plus or minus 2i over 5, that kind of thing? Those are complex numbers. All right, let's do number 2. Now we know what these words mean. Let's see. To which of those sets does -7 belong? It's an integer. What? It's definitely real,
Rational.
and it's rational. It's rational. It's an integer, it's rational, and it's real. Wait, is it complex?
No.
Wait a second. Can we write it as -7 plus 0i?
Yeah.
It is complex. Every number that you know at this point of your life is complex because they can all be written like that. A and B don't have to be non-zero. A can be 0, B can be 0. Okay? All right, what about root 32? Irrational,
Complex.
Whole.
complex,
Wait, no.
and
Real.
real. Yeah. We didn't talk about it. We as our example for irrational, we use pi. But guys, every radical that doesn't go away, like square root of 4 is rational, but the square root of 5, irrational. But when I type it on my calculator, it stops. No, it doesn't. Your calculator stops, but the number doesn't stop. Okay, so it is irrational, real, and complex. How about 6?
Natural. Whole. All of them.
6 is all of them except what? What is 6?
Irrational.
All of them except pure imaginary.
It's not, oh, I should have said B can't be 0 here. Okay, so yeah, it's not pure imaginary, and it's not irrational, but it's all the rest. How about the square root of -4?
Pure imaginary.
Pure imaginary and complex. -2/3.
Rational.
Rational, real, complex. Everybody okay? All right, number 3, these are our properties. Take a look at that list. Does anybody know any of them? Let's see how much time I got here. Anybody know any of those? We don't have to go in order.
Distributive.
Okay, somebody knows distributive. What do you know about it?
That you multiply the number on the outside propensity into the things on the
So
inside.
A times B plus C equals AB plus AC. Now, you're exactly right. Please understand that properties go in both directions. So in other words, if you had a problem that said, 7x plus 14y equals 7 times x plus 2y, that would be distributive. When you factor, you're using the distributive property kind of in reverse of how you're used to thinking about it, right? Good deal. Okay, who knows another one? Anybody know any of the other ones? Yep.
Identity. Like addition and subtraction, just be plus or minus 0.
Actually, we don't really talk about subtraction or division. We have addition and multiplication.
Times 0 and plus 0.
And let me explain why that is. In like pure math, there's no subtraction because subtraction is simply adding the opposite, right? And then there's no division because division is simply multiplying by the multiplicative inverse, yeah. So basically we don't have properties for those two things. Okay, what's the identity say?
A plus 0 equals A.
And for multiplication, A times 1 equals A, right? Those are the identities. Beautiful. All right, anybody know another one? Yep. The inverse properties, and again, we have additive inverse, and we have a multiplicative inverse. Okay, what do those say?
The multiplication one is like a fraction times its inverse is 1.
So A times 1 over A equals 1. And the stipulation there is obviously A can't be 0. 0 has no inverse multiplicative. What's the additive inverse? A plus opposite of A?
Oh, yeah.
Yep. So what the inverses do is get you back to the identity. So the additive identity is 0. Add 0. The additive inverse gets you back to 0, cancels out, these cancel. All right, anybody know commutative and associative? Oh my goodness gracious, yeah.
Associative, if they're all multiplication or addition and they're parentheses, you don't really need them. Like it doesn't really matter what order you do it in.
Watch that word. Associative, I understand, I know exactly what you're saying, but we have to be careful how we say it. Associative doesn't really involve order of the numbers. It involves the grouping.
But yeah, that's what.
Yeah, so the A, B, and C are still A, B, and C, but here we do these two first, and here we do this one first, okay? And then for multiplication, the same thing. So associative is a grouping thing. Now what's commutative? That's the order thing. So when we do,
Happy first day?
thank you. So commutative addition means that when you add two numbers, the order that you actually add them doesn't matter. 5 plus 2 is the same as 2 plus 1. And that's second nature to you guys, but it has a name. It's commutative. And then the same thing for multiplication. The trichotomy you may have never heard of before, and it's going to be incredibly obvious to you, but it's one of those things that we need to complete proofs sometimes. Oops, better spell it right. Trichotomy says that given two real numbers, A and B are both real, either A equals B, A is less than B, or A is greater than B. So basically the trichotomy says that there are three relationships that can occur between two real numbers. They're equal, the first one's less, or the second one's less. That makes sense, right? I mean, that's obvious. Just never had a name before. All right, part 4, here we go. What's property A? The additive identity. Guys, you gotta be specific. There's two identities, so choose the appropriate operation. So additive identity. All right, what about B?
Additive, associative. Additive, associative.
This word's a trick story.
Oh, additive, commutative.
That's commutative. Why is it commutative? What changed? The order, that's right. The order of the letters changed. Yeah, there's parentheses in there, but they didn't change. The order did. That's commutative of addition. What about C?
Multiplication, associative.
That is right. That's associative and multiplication, yeah. And you can abbreviate. D. Additive inverse, yep. Additive inverse. What about E? Multiplicative inverse, multiplicative inverse. How about F?
That is,
Commutative
Multiplication.
multiplication, yep, that's commutative multiplication. How about G? That's distributive. That's distributive. How about H?
Multiplication, identity.
Multiplicative identity, right? You can abbreviate, don't worry about it right now, big words, you can abbreviate. And I.
distribution. Inverse.
Inverse.
Yeah, that's the multiplicative inverse. Because 1/5 times 5 is 1. All right, part 5. Now we're gonna change fractions into decimals and the decimals into fractions if possible. All right. Now, you guys are incredibly bright. Most of you are gonna look at A and know that the decimal is 0.6. And you will have different ways of doing that. But the meat and potatoes way, the way that will work with every problem, is to do a division. Okay? I'm not saying you have to. If you know that's 0.6, write 0.6. But for ones you may not know, like 2/7 or something, you can divide. This means 3 divided by 5, right? And that's what we do when we convert decimals into, or fractions into decimals. All right, so do B for me. Tell me what B is. Go ahead and work it out. Or maybe you just know. What is it? 1.6. Repeating?
Yeah.
5/3, 1 2/3. Everybody good? Remember, it's your job to raise that hand if I say something you don't get. All right, do -8/9 for me. What's that one? -8/9. I heard somebody say it already. Negative 0.8, yeah. So 8/9 negative is negative 0.8. Repeating. Now, again, I know that. He knows that. I don't know about him. I love math. I do it all the time. Good Lord, I've been doing this forever. If you don't know what that is, you're going to do this division, right? That's how we do it. We do the division. You're going to say, okay, well, that's going to go in 8 times. And then you're going to notice that it keeps repeating, right? All right, we'll pick up here tomorrow. Good job, guys. Pack up. Bring those blue sheets back to me. And remember, where you sit tomorrow is your